Yo, greetings and celebrations of the upcoming Halloween weekend. Hope you guys have fun this weekend. Be safe. Until then, I need to ask you a quick question. How would you like to be able to find the degree of a polynomial and arrange the terms of a polynomial in ascending or descending order? I'm sure that's tops on your list of things to learn, so that's what we're going to do tonight. A polynomial is a monomial that is added or subtracted from another monomial. So, in other words, a polynomial is made up of monomial or a sum or difference of more than one monomial. But beware, it is the Halloween season. We've got to beware of something. And what we're going to be aware of is that when you have a number in the denominator, that expression is not a polynomial. Now, tell me if each of these are a polynomial or not. 2y minus 7x plus 1. Give it some thought. Okay, I hope you said yes because this is a polynomial. There's no numbers in a denominator anywhere. We're subtracting and adding monomials. How about 21? X cubed y squared. Once again, this is a polynomial. There's nothing in the denominator, and we have numbers straight across in a monomial format. And what about 2x divided by y times z? Well, I think you've already seen this is in the denominator, which means this cannot be a polynomial. So the answer to this one is no. Now, let's take a look at some of these tiles. Tiles are a good way to study polynomials because they give you a visual other than the abstract number. So here we're going to count the red squares as an x squared, the yellow squares as an x, and a green square as a 1. Now, if you're colorblind, the big square is x squared, the rectangular squares are x's, and the small squares are 1's. So if you will, put together an expression that would be true for this tile arrangement and see if you can find it in the table here. I hope you picked number 3. We have 1x squared, that's here. We have 5 x's, 1, 2, 3, 4, 5. And we have 6, 1, 2, 3, 4, 5, 6. So hopefully you picked number 3. Now, let's talk about this term degree. In a monomial, when we're talking about degree, we're talking about the sum of the exponents of all the variables. So we're going to count up in the monomial the exponent for every variable, and that becomes the degree. So here, let's see if you can determine how many degrees are in each of these monomials. And now, I hope you could see that with number 1, we had one variable. It had the exponent of 2, so its degree is 2. With the second problem, or second monomial, there are 3 variables, 4, 3, and 1. That totals 8. So I hope you got 8 degrees for this. Once again, that's 4 plus 3 plus the 1 with the c gives us 8. So we have 2 here and 8 here. Now, with negative 3, there is no variable, so we have 0 degrees. Goose egg, nada. Now, what about degrees in polynomials? This is going to be a little different. Degrees in polynomials, what we're going to do is we're going to look at the degrees in each of the different variables. So we have 2 here, we have 1 here, and we have 0 there. And what we're going to do is look for the largest degree in the polynomial, the largest single degree, and that will become the degree for the polynomial. So in this case, the largest number is 2, so we say this is a second degree polynomial. All right, let's try this one. I'll give you a chance to work this one on your own. Remember to identify the exponent associated with each of the variables. And if you have more than one of the same variable, be careful. Okay, so we see here we have 7, here we have 4, and here we have 8. 4 for the x and 4 for the m. So that total of 8 is the largest, and so it's also the degree. So we would say this is a polynomial in the 8th degree. Now, find the degree of this expression. I hope that your answer choice was 4. We have 3 here, 2 plus 2 here equals 4, and of course the 8 has a 0. So the 4 is the largest, and our selection 4 was 4. Now, what do we call when we go from small to big? If we go from A to Z, if we go from 1 to 100, what do we call that? Going from small to big. And then also, what are we going to call it if we go from big to small? What if we start with the Z's and are going down to the A's? You've probably seen this in your sort window, either in a spreadsheet or in a Word document. So go ahead and think about this for a second. Small to big, big to small, and see if you can come up with the appropriate term. This one, ascending order. What is ascending order? If you ascend, you're moving up, and so we're moving from small to big, moving up. What about going downward? Going downward, we are going to say, what is descending order? Descending, going down, you descend stairs, you go to a lower point in the stairs. So we're going from big to small, we call it descending order. Now, remember, we're using the degrees to do this. So I want you to now take a moment to put this in descending order. What you should have gotten is x4 minus 3x2 plus 8x minus 4. 4, 2, 1. 4, 2, 1. And then, of course, the 0. Now, I want you to take this problem and put it in descending order, but I want you to do it in terms of x. And what we end up with is the negative 6x3, because this was the largest degree for the x. That's followed by the 12x2y3, because the x2 is the second largest degree for x. Then comes our minus 2x, because 1 is the third largest, and so on. So we've done this in descending order from the highest to the lowest. Now put these in ascending order in terms of y. Now remember, you're looking at the degree for each y, and you're going to go from the smallest one to the largest one. You give it a try. And what we end up with is we start with the negative 2x because there is no y. Can't get any lower than that. Then we have the 3y, which carries a 1. We have minus 6x to the third times y to the second, which is a 2, plus 12x squared y to the third. So as you can see, we had 0 here, 1 here, 2 here, and 3 there. That is in ascending order. Now, try this one. Put this one in ascending order. And since we only have one variable, I don't have to define. We're going to do this in terms of A. Okay, and I hope what you ended up getting was negative 3 plus 2a minus a squared plus 5a cubed. And again, we're going from ascending order, so we're going smallest to largest. This has got a 0 degree, a 1 degree, 2 degree, 3 degree. 0, 1, 2, 3, ascending order. Now, you may want to practice some problems on this before we actually get into adding and subtracting polynomials. It's going to do you really good to get in and see this work and try some problems. And I'll be glad to post some of these answers for these problems in the text so that you can work them and then check your work. Page 459 would be the place to go to find some appropriate problems. And there's also a nice review of this topic on pages 456 to 458. So if there's something about it you're not clear on and you want to refine your notes, go to your text, 456, 458, and get those notes all tidied up. As always, I'm happy to be here in the classroom and I'm looking forward to your return. Cheers.